Thank you for joining us. I'm David Clemens, Sales Manager for Highway Products with Wheeler. We design and supply bridges and related components. The presentation will review two design aids provided by the National Steel Bridge Alliance and the Short Span Steel Bridge Alliance. We will also review a case study using prefabricated steel bridge components. The Short Span Steel Bridge Alliance is a group of bridge and culvert industry leaders, including steel producers, fabricators, service centers, coaters, universities, owners, and trade organizations, who have joined together to provide educational information on the design and construction of steel bridges for installations up to 140 feet in length. It is the first industry-wide effort to provide educational and design support for short-span steel bridges. The Alliance provides educational information for all steel solutions. Based on the size of your crossing, a specific steel structure may be more advantageous than another. Whether it be corrugated steel pipe, structural plate, rolled beam, or plate girder, steel has the solution. The National Steel Bridge Alliance is a nonprofit organization representing the entire steel bridge design and construction industry. NSBA and the Short Span Alliance work together to promote short span steel bridge applications. With support from FHWA, NSBA has hired HDR Engineering to update and complete the Steel Bridge Design Handbook, which is comprised of 23 separate units and 7 design examples. Each unit is developed by prominent engineers in the field and reviewed by committee. Units and design examples are current with the AASHTO LRFD Bridge Design Specifications, 3rd edition US. A complete overhaul of all units will bring the handbook up to the most current edition of the AASHTO specification within the coming years. NSBA has 2 complementary software design aids to help local transportation engineers and officials with steel bridge design. Simon is a software for preliminary steel and box girder bridge design and can be downloaded for free from the NSBA site. Splice is a design aid for bolted connections. In June 2012, the Short Span Steel Bridge Alliance launched a new design tool, eSpan 140. This free web-based system provides a one-stop shop to attain customized steel solutions for a specific project. To begin, simply go to espan140.com to create an account. Your account will allow you to save all the design inputs you provide, make changes to existing designs, and share your steel solutions with others. Next, you input specific project details. Information such as length, width, ADT, and pedestrian requirements are entered in order for the tool to provide you with optimized steel solutions. Once you submit your data, a customized solution book is developed for you to download and share with others. The book provides standard details for rolled beam and plate girder bridges, as well as corrugated steel pipe and structural plate solutions specific to your project. In addition, prefabricated options are provided, a list of industry contacts to help build your bridge. It is truly the only place you have to go to get all the information you need to consider steel for your next project. This case study is an example of accelerated bridge construction. This looks like a fairly typical bridge. The difference is in how it was delivered. Not just the components, but the process. Rather than design, bid, build, the owner chose design, supply, and prefabricated components. The project was sponsored by the Utah DOT for a bridge in Axtell, Utah. It was designed by a local consultant, Jones & DeMille. The consultant surveyed the site, performed hydraulic analysis, and sited the bridge. Typical local engineering. Working with the DOT, they determined the structure type. They chose a prefabricated steel structure with a cast-in-place deck and a crash-tested railing. Based on preliminary analysis, they felt the steel beams offered a shallower depth of section and more cost-effective option versus precast concrete beams. Specifications were developed to ensure material and design standards. The profile designated the position of the bridge with the final plans would be the responsibility of the contractor and/or their supplier, in this case, Wheeler. Wheeler used the consultant's plan details to develop the final bridge plan. This allowed for advantages using the fabricator's preferred details and the contractor's input on installation preferences. Wheeler coordinated with the contractor, Gerber Construction, to detail the bridge. The cross-section featured 4 steel beams. The beams were shipped in pairs or tandem. Shop-welded diaphragms connected the interior and exterior beams. Field-bolted diaphragms connected the interior beams. Typical details were used for the cast-in-place deck. Stay-in-place forms or precast panels can be used, but the owner specified a cast-in-place with temporary forms. A commonly used crash-tested railing attached to the concrete deck. Finished plans were submitted for review. The bridge was released for fabrication after plan approval. Steel was procured, cut to length, bearings were added, and the beams were laid out, creating the tandems. The bridge was on a grade and slightly skewed, which created a complex layout to meet the finished elevations. When the layout was complete, welded diaphragms were added. Stubs were added to the interior beams for the field-bolted diaphragms. The contractor requested the shear studs be shop installed. All the steel was sandblasted to promote even weathering. The specifications required weathering steel for the beams and galvanizing for the railing. The tandems were loaded for delivery on 2 trucks. Diaphragms, railing components, and miscellaneous items were bundled and shipped with the beams. Delivery was coordinated with the contractor after the bridge abutments were prepared. The short-span steel bridge alliance arranged to document the installation of the bridge. A film crew was hired to film the erection of the steel beams. The beams arrived on the site, and the contractor positioned the crane to pick them off the truck. Rigging was prepared. Horizontal lifelines were temporarily attached to be used when the workers would bolt the diaphragms in place. The first beam pair was swung into place on the abutments. Holes were marked for the anchor bolts. Drill and epoxy anchors were used instead of cast in place. This assured a proper fit. After the holes were marked, the beams were temporarily shifted while the holes were drilled. Once the anchors were prepared, the beams were set in final position. Then the second beam pair was prepared. You can see them lifting the field-bolted diaphragms. The diaphragms were bolted to the second tandem before it was installed. The second tandem was lifted and swung into place. The same procedure was used to install the anchor bolts. After the anchors were finished and the tandem was in its final position, the contractor completed the assembly of the interior diaphragms. In the course of one day, all beams were set, anchored, and bolted into place. Later, the concrete deck was formed and poured. After curing, the railing was installed. Here is a picture from under the deck. You can see the bolted diaphragms and remnants from pouring the concrete deck. The weathering steel patina has begun to form. The railing was a crash-tested design incorporating tube rails and open-shaped posts with typical transitions for the plate beam approach railing. All of the railing components were shop fabricated and hot dip galvanized. This is an example of accelerated bridge construction, taking a conventional bridge and delivering it faster and more cost-effective. The contractor was complimentary of how the materials arrived, the ease of assembly, and estimated they saved 3 to 4 days on site by receiving the beams in tandem as opposed to receiving individual beams. The DOT and consultant were very impressed with the process. By relying on the supplier to provide the final plans, they saved time and money developing the project, and the schedule was moved up, resulting in the bridge being replaced sooner. For future projects, they can now use E-span 140 for preliminary sizing of the bridge. Try it for yourself. Here are websites where you can find these and other valuable tools. Please contact us with any questions. Again, thank you for joining us with this unique Lotrans virtual conference. Hopefully you found some tools that will help you in your next project.